Okay, folks, here we go. 7.6, the cross product of two vectors. The cross product, A cross B, between two vectors, A and B, results in a third vector that is perpendicular to the plane in which the given vectors lie. For example, when we need to, the cross product will result in a vector. The formula to calculate the vector is as follows. Now this can be very, very complicated, but basically, in order to find the x values, we multiply the y and z values of the corresponding vectors and subtract them. To find the y value, we multiply the x and z values and subtract them, and to find the z value, we multiply the x and y values to subtract them. The problem is a lot of kids mix it up. In fact, I've been known to mix it up sometimes too. And so this is the actual formula to calculate the cross product. But I find that mistakes can easily be made, and as a result, we get the wrong vector. So let's look at an easier way to be able to calculate the cross product. So, example 1, determine the cross product of A and B if vector A is equal to this vector and vector B is equal to this vector. So, to find the cross product, we write A cross B, and what we do is write each vector out twice, vertically. So there's our first vector, vertically. There's our second vector, vertically. So notice we write it out, our first vector twice, going down. That's his first vector twice. That's vector A, because that's the first vector. We have vector B, that's the second vector, and we write that out twice. And what we do here is the very most important step is we're going to do cross product. So we cross out the top and the bottom. And we're going to create something called a lattice. So the idea is a cross product. So, for example, to find the cross product, we take the first, in the first column, that first number after we cross it out, and multiply by the next number across. So going across. So 7 times 5, which is 35. And we're going to subtract the lattice. So let's look at the lattice again. So we're going to subtract the product of negative 3 times negative 2. Negative 3 times negative 2 is 6, so we subtract 35 minus 6. And then we do the same. That is going to be our x value of our cross product. So our x value of our vector, which is a result of the cross product. Now we need to find the y value. So what do? We take multiply the next number times negative, so negative 3 times negative 4, which is positive 12. And then we multiply we subtract the product of 2 times 5, and that gives us 10. And we subtract those. And then finally the last one. Again, for z, we multiply 2 times negative 2, which is negative 4, and we subtract 7 times negative 4, which turns out to be negative 28. So, when we calculate the cross product over here, you will see that 35 minus 6 is 29. And then the next value is 2. And finally, the third value is going to be positive 24. And that, folks, is the cross product. And if you look at the little cross that we've made over here, we can see that this looks like a shoelace. And that's exactly what we're trying to do, is create a shoelace pattern, so that there is the cross product that we're going to actually determine. So again, it's the shoelace pattern, and this is what we're trying to do with this. All right, let's look at the next one. Some properties of cross product include A cross B is equal to the negative direction of B cross A. So it's very important to note that when you do cross product, you are not able to do it backwards as you are in dot product. You change direction. When you change the cross product from A to B to A, you're also changing the direction. So it has to go in the opposite direction. Next part is that if I have the cross product of a sum, of two vectors, that is equal to the sum of the individual cross products, noting that the first vector right here is the first vector in both cross products. That's going to be important as well, again because of the very first property listed there. The next one is if you have a scalar value multiplied by a vector and you've got a cross product of another vector, well, that scalar value can be applied to either vector or removed completely from the cross product. And that's going to be important when you have to actually simplify certain aspects of cross product. Alright, so these are the properties of the cross product that we've gone through. Let's look at another example. Let's say you're asked to determine a normal unit vector to a plane that has vectors -2, 6, 4 and 2, -5, 6. So these are two vectors that lie on a plane, and we want to calculate the normal unit vector. Well, what does that mean? Well, we need to calculate a vector that is perpendicular to the plane, okay, and it's a unit vector. Well, what does that mean for us? Well, first of all, let's name the vectors to make our lives a little bit easier. And what are we looking for? Well, a normal vector to a plane is a perpendicular vector to a plane, and therefore probably should calculate the cross product, because again, cross product is a normal vector to the two vectors that lie on the plane. So vector A cross vector B is equal to, now let's do the cross product the way we listed it before. So that means we do -2, 6, 4, -2, 6, 4. So repeat the vector twice going down. And then we repeat the second vector going twice. We cross out the top and the bottom. And guess what, folks? Now we're going to create our shoelace pattern. So it's going to be 36 minus -20. 8 minus -12, and 10 minus 12, and we end up with a result of 56, 20, and -2. So the next part is we need the normal unit vector. So we have the normal vector, now we need the normal unit vector, which means we have to calculate the magnitude of that cross product. Magnitude of that cross product is as such, so that we have the square root of 3,540. Now 3,540 can be simplified so that the normal unit vector will result in 1 over root 885 times the unit vector of, or times a vector of 28, 10, and -1. And that's simplified. So this is the normal unit vector, a normal unit vector to this plane. Hopefully this helps. We're on to the next part. Note, something about dot product. We commonly refer to the dot product as something called the scalar product because the result will be a scalar value. Now the cross product can be referred to as a vector product. A vector product, okay, means that the result will end up being a vector. So we have A and B such that if you have a vector, let's say A and B, we have the result will be two vectors, either A cross B or B cross A, depending on the direction that we're looking for. Okay, now a lot of times students have a hard time with direction. So we're going to go to something later on called the right-hand rule, and we'll be able to tell whether that red vector right here is actually pointing out of the page or the green vector is pointing out of the page. It's going to be important to find that direction that it's going in later on in this course, so it's important now just to understand which way it's going. So later on in this video, you'll see the right-hand rule pop up. In the meantime, cross product can be verified by taking the dot product, and we use this to check our answers. And this check, when you have time, it's a good idea to check your answers because if I take the dot product of the A vector with the cross product, what that will result in, okay, the dot product of the cross right here will result in a value of 0. And that will be the same as if I took the dot product of the B vector with the cross product. And they both have to equal 0, okay, because the vectors A and A cross B are perpendicular, as well as the vector B and the cross product are also perpendicular. So your result should be 0 if we took the dot product if we know all the values. Let's go and look at an example. Example number 3 talks about calculate A cross B if vector A is a certain value and vector B is a certain value. Check your answers. So again, we take the cross product and we take vector A and write it out twice, and we take vector B and write it out twice. As a result, don't forget that we cross off the top and the bottom and we calculate the cross product. The cross product will be -4 minus -3. Next will be 9 minus 10. And the last one will be -5 minus -6. So our resulting vector from the A cross B will be -1, -1, and 1. Let's check our answers. So let's check A cross dot the cross product. And it turns out A dot the cross product will equal -5 plus 2 plus 3, which gives us 0. Now check the other one. B dot the cross product vector will result in the B vector dot the cross product vector, and the result here will be -3 plus 1 plus 2, and that equals 0. So we need to check both because we want to ensure that the vector product is perpendicular to both vectors, so that the cross product that we get, or the vector product, the value is perpendicular to both vectors. And this is important, and we can use our check to check this. All right. Earlier I mentioned something called the right-hand rule. So we're going to go over this in a little step. Here it is in general, but let's go back and take this one step at a time. First of all, your thumb is going to be your direction. It directs you where you're going to go. First one. Place your right hand pointer or index finger on the first vector in the cross product. So if you have A cross B, you put your index finger pointing in the direction of A. Now, you let the other 3 fingers follow the second vector, or you can just let your middle finger follow the second vector. Step 3, your thumb will naturally point in the direction of the cross product. So, for example, if you have these 2 vectors here, if I write for B cross A, what you're going to have is your thumb will point out of the page. If you have A cross B, your thumb will naturally point into the page. And you can do this by the demo that your teacher will show you. Anyways, hope this helps, folks. Have a great day. Take care.